Okay, question number 5. We have a composite function, so g of x equals f of the sine of 2x. F of x is unknown, but differentiable for all values of x. Therefore, it's continuous, no sharp joins. Use the following information for f and f dash. So this is about f. Okay. Find the value of g of pi on 6. G of pi on 6 will equal f of sine of 2 pi on 6, which is pi on 3. Sine of pi on 3, put back into radians. Pi divided by 3 is root 3 on 2. So it's going to equal f of root 3 on 2, and f of root 3 on 2 is equal to 3. So it equals 3. 1 mark. Good evening. Okay, so part B, show that g dash of pi on 6 is equal to 1/9. And I know that this is what g dash of x equals. So g dash of pi on 6 will equal 2 times the cos of 2 times pi on 6, which is pi on 3, times f dash of sine of 2x. F dash of sine of 2x, which is f of sine of 2x, but the derivative of it. And I know that f of sine of 2x is the same as, so I want f dash of root 3 on 2, and f dash of root 3 on 2 is 1/9. So that's 1/9. And this is 2 times a half. So that gives me 1/9. Part C, find the equation of the tangent to g at pi on 6. The equation to tangent at g, the equation to g of pi on 6. So g of pi on 6 I know to equal 3, because I did that up here. Therefore, that's equal to 3. So I know a point. I know pi on 6 and 3 is a point on the curve, and g dash of pi on 3 is pi on 6 is equal to 1/9, the answer from the last question, so the gradient is 1/9. So y equals 1/9 x plus c, and I can do that here. Y minus 3 equals 1 divided by 9 bracket x minus pi on 6. And if I go solve for y, that gives me y equals 1/9 x plus 3 minus pi on 54 as being the equation of the tangent at that particular point. Okay, 2 bits to go. Find the average value of the derivative, average value of the derivative, average value of the derivative. I have a rule for the average value. It's 1 on b minus a, integral of a through to b of whatever it is I want the average of dx. I want it of g dash. So I want the integral from pi on 6 to pi on 8, g dash of x dx, over pi on 8 minus pi on 6. So pi divided by 8 minus pi divided by 6 equals negative. So it's to the larger one minus the smaller one. So it's going to be 6 there. It's going to be 8 there. So that's going to be 1 on pi on 24. So it's going to equal 24 on pi. the integral from pi on 8 to pi on 6. Now, I want the integral of g dash of x. So I want the integral of this, because that's what g dash of x is. 2 cos 2 x times f dash of sine of 2x. dx. Okay, so the integral of this, integral of the derivative of f of sine of 2x dx is sine of 2x, or f of sine of 2x. But for me to be able to take the antiderivative of sine of this, I need its derivative, and there I do have its derivative. So this is going to equal 24 on pi, square bracket, f of sine of 2x, going from pi on 8 to pi on 6, which is 24 on pi, f of sine of pi on 3 minus f of sine of pi on 4, which is equal to 24 on pi, f sine of pi on 3 is root 3 on 2, minus f sine of pi on 4 is root 2 on 2. That's equal to 24 on pi. F of root 3 on 2 is root 3 on 2 f3. F of root 2 on 2 is 5. So it's going to be 24 on pi times minus 2, or minus 48 on pi, should be my answer. And lucky last question, we are looking for the 4 solutions to g dash of x equaling 0 in that interval. And g dash of x is equal to this. So I've got 2 cos of 2x, 2 cos of 2x, f dash of sine of 2x equals 0. Therefore, using the null factor law, cos of 2x equals 0 will give me one set of answers. So cos of 2x equals 0, math 3 given 0, x, and we're going up to pi, and solve for x. And that gives me pi on 4 and 3 pi on 4. They're 2 of the answers. Or f dash of the sine of 2x equals 0. Now I know from this table that f dash of x equals 0 when x equals root 2 on 2. So when sine of 2x equals root 2 on 2, then I will have f dash of root 2 on 2 equaling 0, and that is correct. So I'd like to do the sine of 2x equals fraction root 2 on 2, given x goes from there to there, interactive advanced solve, and I get x equals pi on 8 and 3 pi on 8, and there are my 4 answers.